Hello students, I am Sachitrakar. Welcome to Cars Physics. This is my lecture 3 on kinematics and we are continuing motion in a straight line. In this class, we will discuss only some fundamental numericals based on distance and displacement. Okay, let's start. Question number 1. A boy travels 8 meters along east, then 6 meters along north. Then we have to find distance and displacement of the boy. Okay. Before solving the question, I have represented the respective directions north, south, east and west. Okay. Then 8 meters along east. Let the boy starts from O. This point is a length of straight line represents magnitude 8 meters and directed towards east. Then move 6 meters towards north. This is along north, so this displacement is 6 meters. Okay. Let final point is B. Then the boy starts from O and final reaches at B. We have to find distance. Distance is actual path traveled by a body irrespective of direction, or distance is actual path length of the body. Okay. The boy starts from O, moves to position A, then path length is OA. Then from A to B, irrespective of direction, distance is irrespective of direction. So path length OA is 8 meters, path length AB is 6 meters, then 14 meters is distance traveled by the boy. Then we have to find displacement. O is initial point, B is final point, then displacement is shortest path directed from initial to final point. So displacement is OB. Okay. See students, this is along east and this is along north. So obviously this angle is 90 degree, theta is 90 degree. So OAB is a right angle triangle, the same place to it, and it's also the first and very easier question. Okay. So OA is base of right angle triangle OAB and AB is perpendicular, so OB is hypotenuse. So length of OB represents magnitude of displacement. Then if this displacement is S, then magnitude of displacement is length of OB, that's equals to square root of OA square plus AB square. Okay. And this is equals to square root of 8 square plus 6 square. So magnitude of displacement is 10 meters. Okay. Then we have to get direction of displacement. Let this angle is alpha, means resulting displacement makes an angle alpha with x-axis, and again x-axis is taken along direction east. Okay. Then from right angle triangle OAB, tan alpha is equal to perpendicular AB, base is OA, thus perpendicular AB divided by length OA. Then tan alpha is AB 6 meters, OA 8 meters, then tan alpha is 3 by 4. So if tan alpha is 3 by 4, if tan alpha is 3 divided by 4, then this is the right angle triangle. This angle is 90 degree, this angle is alpha, then this is perpendicular 3 meter, base 4 meter, and this is hypotenuse. Obviously square root of 3 square plus 5 square, this is equals to 5 meter. If tan alpha is 3 by 4, then alpha is 37 degree. To simpler values, we should remember, if tan alpha is 3 by 4, then alpha is 37 degree. If tan alpha is 4 by 3, if tan alpha is 3 divided by 4, then alpha is 37 degree. Similarly, if tan alpha is 4 divided by 3, then alpha is 53 degree. Say here alpha is 37 degree, means tan alpha is 3 by 4, then hypotenuse is 5 meter. Then you can also find sin alpha, cos alpha, etc. Sin alpha is 3 by 5, cos alpha is 4 by 5. Similarly, when tan alpha is 4 by 3, then this is 4, this is 3, this is also 5. Then also you can get all the angles, and which will be useful in future problems. Okay. So this is distance, this is displacement. Direction of displacement is 37 degree, means resulting displacement makes an angle 37 degree with east. Okay. Two fundamental. Then question number 2. Question number 2. A man starts his motion from origin. Let origin O, coordinates of origin are 0, 0 along x-axis. Man travels along x-axis, reaches at a point P where coordinates are 20 meter and 0. Then returns to a point Q where coordinates are minus 20 meter and 0. Okay. We have to find distance and displacement of the man. Very easy question. Then let's represent the respective axis. This is x-axis and this is y-axis. Okay. The motion is along x-axis. This is origin. Coordinates of origin are 0, 0. Okay. Value of x is 0, value of y is 0, and the man starts his motion from origin. He reaches at a point P. P is 20 meter, 0. So obviously the man has moved along positive x-axis direction. Let this point is P where the man reaches and coordinates are 20 meter and 0, and returns back to a point where this point is Q. The coordinates are minus 20 meter and 0. So you have to find distance. Let's first find distance. As we know, distance is actual path length or length of path irrespective of direction. The man travels from O to P. Path length is OP, then returns from P to Q, then path length is PQ. Okay. See, from the given coordinate system, distance of P from O is 20 meter and also distance of Q from O is 20 meter. Then OP, length of OP is 20 meter and length of PQ, P to O is 20 meter, again O to Q is also 20 meter, total length is 40 meter. So displacement of the man is 60 meter. We have to find displacement also. Displacement, as we know, the shortest path directed from initial to final position. The man starts his motion from origin, goes to point P and finally returns back to point Q. So O is initial position, Q is final position. So direction is from O to Q. This is the resultant displacement, means from O to Q. Length of OQ represents magnitude of resultant displacement. So magnitude of resultant displacement is 20 meter, and considering the direction, resultant displacement is minus 20 meter because direction is reversed as compared to original direction. The man moves from O to P, then OQ is opposite to the direction of OP. Okay. Also, we may put here resulting displacement. You may take minus 20 I cap or 20 minus I cap. Unit is meter. Okay. I cap is unit vector along x-axis. So this is along negative direction. So we may take minus I cap. Okay. So this question can be turned in different ways. Okay. See, suppose if the question were asked like this: a man starts his motion from origin O where coordinates are 0, 0, reaches at a point P where coordinates are 20 meter and 0, and returns back again to initial position or O. Then we have to find distance. Distance is actual path length. Man goes from O to P, path length is OP, then returns back from P to, means again path length is PO irrespective of direction. Distance has no definite direction. So OP plus PQ. From O to P distance is 20 meter. Again from P to O distance is 20 meter. Total distance is 40 meter. Again displacement obviously 0 because O is the initial position, O is final position. Man has returned back to initial position. So shortest path from initial to final, initially is O, final is O, so displacement is 0. Okay. Suppose this question were asked like this, I am changing the question. See, Suppose a body or an object starts its motion from origin where coordinates are 0, 0, reaches at a point P where coordinates are left 3 meter and 0. Okay. Then moves from P to a point Q where coordinates are 0 and 4 meter. Okay. We have to find distance and displacement. Okay. See, this is along x-axis, this is along y-axis. Obviously, this angle is 90 degree. So from O to P, distance is 3 meter. From O to Q, distance is 4 meter. So from the right angle triangle, OPQ. PQ is hypotenuse, so PQ. Length of PQ is square root of OP square plus OQ square. Base perpendicular, so that's equals to square root of 3 square plus 4 square. So PQ is 5 meter, PQ is 5 meter. Okay. Then we have to find distance. Distance is actual path traveled by the object irrespective of direction. Actual path length. The object moves from O to P, path length is OP. Then moves from P to Q, path length is P. Then OP is 3 meter, PQ is 5 meter, then distance is 8 meter. Then displacement, we can get displacement. See, O is initial position, Q is final position. The direction of displacement, resulting displacement directed along positive y-axis means from O to Q. And magnitude of displacement is 4 meter, or taking direction into account, you may take 4j cap, unit is meter. Okay, so you can call the question in different ways so that you will strengthen your fundamental. Okay, if you are getting one question, then solve it fast. If it is easier to solve, then think alternate questions which may be formed using the same question. Okay, if you analyze the question, you may draw different types of questions from a given question. You can get it. Think the question. Okay, what's the concept behind the question? What is asked? What again can be asked by using some other data. Okay. So analyze both. Try to analyze the questions and you will get the fundamentals. Okay. The basic thing is to strengthen your fundamentals so that you can attempt any question without fear. Then question number 3, some extent different. All the questions are different from each other, and I hope today's discussion will help you to strengthen your fundamental standard. Okay. A boy or a car travels 30 kilometers along north, then takes a perpendicular right turn, moves 30 kilometers, then takes a perpendicular left turn, moves 10 kilometers and stops. Question is like this: a car travels 30 kilometers along north, then takes a perpendicular right turn, again moves 30 kilometers, then takes a perpendicular left turn and moves 10 kilometers and stops. Okay. Let's represent as the directions we have taken. Let the car starts from O. Okay, initial point is O. Travels along north. Displacement is O, means 30 kilometers along north. Then takes a perpendicular right turn. See, the car is traveling along north, takes a perpendicular right turn. This is right hand, perpendicular right turn. So let it moves from A to B through a distance 30 meters. See, if you take perpendicular right turn while moving along north, then obviously this direction is towards east. Okay. Then takes a perpendicular left turn. This is left hand, moving along east, and takes a perpendicular left turn. Obviously, if you take perpendicular left turn while moving along east, the direction will be towards again north. This is along north. Let this point is C. Direction is towards north. Okay. Then displacement is 10 meter and the car stops at point C. O is initial position, C is final position. We have to find distance and displacement. Okay. Let's find first distance. Distance is actual path length irrespective of direction. Path length OA, then path length OAB, then path length BC. Total path length 30 kilometer. 30 kilometer plus 30 kilometer plus 10 kilometer. So total path length is 70 kilometer. This is distance, actual path traveled by the car. Then displacement. C. O is initial position, C is final position. So this is displacement directed from initial to final position. We have to find resulting displacement S. Magnitude of S is length of straight line OC. Then we will calculate direction. If this question means the displacements given in respective directions can be represented by taking coordinate system, motion on a plane along x-axis and y-axis, then it will be made very easier. Direction north is along y-axis, direction east is along x-axis. Okay. Let's represent the respective displacements. This is O, initial point of start. First moves 30 kilometer. Let's represent me. Let's represent I am moving. I moved from O to B. Then the displacement is S1, 30 kilometer. Okay. I am sitting in the car and I am moving. For me, displacement is 30 kilometer with relation to ground or earth. Okay. S1 is 30 kilometer. Then S1 vector is 30. Direction is j cap along y-axis. Then displacement S2 is again 30 kilometer. Direction is along x-axis. So unit vector is I cap, and finally displacement is S3. 10 kilometer along y-axis, again it's j cap. So total displacement in vector form, S1 vector plus S2 vector plus S3 vector. S1 vector is 30 j cap plus S2 vector 30 I cap plus S3 vector 10 j cap. See, 30 j cap, 10 j cap are along y-axis. So resulting displacement is 30 I cap plus 40 j cap. Okay. This is x-axis, means along east. This is y-axis, means along north. Okay. So displacement along x-axis is 30 I cap. Let's check. This is Sx. Displacement along x-axis 30 I cap, 30 meter magnitude. Direction is along x-axis. Along y-axis. Okay. Along y-axis means along north. Displacement is let Sy. That's equals to 40. J cap, 40 meter is magnitude, J cap is direction, unit vector along y-axis. So angle between them is 90 degree. Now calculate the parallelogram. Okay. Then this is diagonal of the parallelogram. See, Sx vector and Sy vector are along x-axis and y-axis. So these two vectors may be the rectangular component of resultant displacement S. Okay, you know vector resolution. How to get rectangular components? S is resultant vector. Sx and Sy are two rectangular components. So magnitude of resultant displacement is square root of Sx square plus Sy square, and this is equal to 30 square plus 40 square. So finally resulting displacement is 50 kilometer. Then direction. Let resulting displacement makes an angle alpha with x-axis. Again, x-axis is represented along east. So this point O, then this is A, this is C. C is final position, O is initial position. Then displacement is OC, means magnitude of displacement is length of line OC, then direction. Resulting displacement makes an angle alpha with x-axis from the right angle triangle OAC, tan alpha. Tan alpha is perpendicular AC. Let this point is B. Length of OB is equal to length of AC. Length of OB represents magnitude of 40 km. So length of AC also represents magnitude of 40 km. So perpendicular is AC. Magnitude represented by AC is 40 km. Then base is OA. Magnitude of displacement is 30 km. 40 km divided by 30 km. So tan alpha is 4 by 3, and as you know, alpha is 53 degree. Okay. So these are simple range questions. You can turn this question. How you will turn the given question? Suppose you will think in different angles so that you can frame the question. Okay. While you are going through theory also, after going through theory, think it, then ask question related to theory to yourself and get the answer. Carry on this process. Then your theoretical concept will be cleared. Then approach problems. While doing a single problem, after solving it, it will feel easier. Then after solving it, think in different ways. How the problem may be turned in different ways. Means you will think about the problem taking different angles into consideration. See, suppose a body moves 30 meter along north, then moves 30 meter along east, then moves 10 meter along south. We will do this type of questions. Number 1, what will be distance and displacement? Number 3, 30 meter along north, 30 meter along east, then takes a displacement of 50 root 2. Say along, this is east, this is north. So along northeast means this angle is 45. Then resolving 50 root 2 into 2 rectangular components out of the vector. So we will approach this type of similar questions. So we can get some idea about the fundamental problems. You will think all these things on different questions. Okay. A body moves 20 meter along north, then 5 meter along east, and finally 8 meter along south. So in similar form we have to find distance and displacement of the body. Okay. It moves 20 meter along north. Suppose the body starts from O, reaches at a point A, the whole path length is 20 meter along north. This is along north. Then moves 5 meter along east from A. This direction is towards east. It moves 5 meter. Okay. So this displacement is 5 meter, and finally moves 8 meter along south. This is along south. This displacement is 8 meter. Let this point is B, this point is C. Then distance. Distance is actual path length irrespective of direction. So total path length from O to B, then from A to B, then from B to C. Then path length is 20 meter plus 5 meter plus 8 meter, and this comes 33 meter. So distance is 33 meter. Then displacement, O is initial position, C is final position. This is shortest path. So OC represents displacement. Okay. To get displacement, just draw a perpendicular from C. Okay. This angle is 90 degree. Let this is any point D. Okay. Then length of AB is equal to length of DC. That's equals to 5 meter. Length of BC is equal to length of AD. That's equals to 8 meter. Then the resulting distance from O to D is 20 meter minus 8 meter. This is equals to 12 meter. Okay. This angle is 90 degree. Then AC, the similar form, right angle triangle. 5 meter is perpendicular, 12 meter is base, and the magnitude of displacement means we have to measure the length of line OC, which is hypotenuse. Then displacement, magnitude of displacement. Then this is S, magnitude of S. That's equals to square root of OD square plus DC square. OD square plus DC square. So this is equals to square root of 12 square plus BC is 5 meter, 5 square, and it will come 13 meters. Again you can find direction alpha. Tan alpha is perpendicular by base, means tan alpha is 5 by 12, then alpha is tan inverse 5 by 12. Okay. These are some easier questions. Fundamental. The next question. Okay. Next question is like this. Number I write in Q. A body moves 30 meter along north, then 20 meter along east, and finally 30 root 2 meter along southwest. Okay. Find, I am writing the complete question, find displacement of the body. Okay. As the directions are given, let's represent first the roughly. Okay. 30 meter along north. Let the body starts from O, and reaches at a point A along north. Distance is 30 meter. Then 20 meter along east. This is direction of east. This is 20 meter. Then 30 root 2 meter along southwest. Students, this is along west, this is along south. So 30 root 2 meter along southwest. Angle between west direction and south direction is 90 degree. So 30 root 2 meter is along southwest. So obviously this angle is 45 or this angle is 45. Okay. I am representing here in the rough diagram. Final displacement is 30 root 2 meter. So this angle is 45. We may take this angle is 45. This question will be very easier if you use coordinate system. Okay. Let's take Cartesian plane. This is y-axis, this is x-axis. Positive y-axis is taken along north and positive x-axis is taken along east. The first displacement of the body is 30 meter along north. So this displacement is 30 meter from O to A. Okay. Then moves 20 meter along east. Let this point is B. This displacement is 20 meter. Okay. And finally 30 root 2 meter along southwest. This is south, this is west. Okay. Then 30 root 2 meter along southwest. Let's represent 30 root 2 meter. Let's take this angle 45 degree. We'll use the method of vector resolution. Resolving 30 root 2 meter into its two rectangular components. The component along, this is west, this is south. Then component of 30 root 2 meter along west, the component is 30 root 2 cos 45. That's equal to 30 root 2 into cos 45, 1 by root 2, 30 meter. Again, another rectangular component along south, this component is 30 root 2 sine 45, again sine 45 is 1 by root 2, then displacement along south is 30 meter. Okay, so another diagram is required to get the resulting displacement. Okay, I am doing here in smaller space. Along north 30 meter, along south 30 meter, along east 20 meter, along west 30 meter, 60 meters, along north 30 meter, along south 30 meter. So these are two displacements along north and south. They are equal in magnitude but opposite in direction. Okay, if two vectors have same magnitude but oppositely directed, then the resulting vector of these two vectors, means resultant of these two vectors will be 0, means 30 meter and 30 meter. Or you may take the unit vectors. Let this displacement is S1, this displacement is S2, this displacement is S3, and finally this displacement is S4. Then total displacement is S1 vector plus S2 vector plus S3 vector plus S4 vector. The resulting displacement is S1, 30 meter along north, means along y-axis 30 j cap. S2, 20 meter along east, means along positive x-axis 20 along x-axis I cap, plus S3. S3 is along west, means along negative x-axis S3 30 meter into minus I cap, plus S4 is along south, means along negative y-axis. So this is 30 meter, negative y-axis minus j cap. Okay, 30 j cap minus 30 j cap cancel each other, means 30 meter towards north and 30 meter towards south are up to give 0 resultant. They cancel each other. Then resulting displacement is minus 20 I cap minus 30 I cap. So resulting displacement is minus 10 I cap, means resulting displacement is 10 meter, direction is minus I cap, means resulting direction is minus I cap, means towards west. So 10 meter towards west. Okay, we may represent here, this is towards west, this is origin, this is 10 meter along west, minus I cap, so direction is towards west. Okay, so this is displacement minus 10 meter towards west. The next question. Next question is a generalized question. I will not use any numerical values or magnitude. I will use only variables, and this question will help to solve the similar type of questions. Okay, a particle moves on a circular track of radius r. It subtends an angle theta about the center of circle. Find distance and displacement of the particle. Displacement of the particle. Okay, this will help to solve similar questions. A particle moves on a circular track. Let's draw a circle. Okay, radius of the circle is r. Let the particle starts moving from a point A. This is center. Suppose it moves in anti-clockwise order. You may take clockwise order. Okay, and reaches at a point B, means position of particle changes from A to B, and it subtends an angle theta about the center of the circle. Okay, then we have to find distance and displacement. Let's find first distance. Distance is actual path traveled by the body or traveled by the particle. The particle has moved from A to B along a curved path, means we have to measure the length of this curved path AB. See students, a very simple formula, you just remember it, it will be very useful to solve the similar questions. So AB is an arc, angle subtended at center is theta by the arc. So the formula is length of arc, ratio of length of arc to angle subtended by the arc at the center. Ratio of length of arc to angle subtended by the arc at the center of circle bears a constant value, means it's a constant. When we use this, we have to get distance, means the length of curved path AB, length of arc is AB, which is distance, curved path AB, length of arc AB, ratio of length of arc to angle subtended at the center theta is constant. Okay, so length of arc AB divided by angle subtended by the arc at the center theta is constant, then this must be equals to total circumference, length of circumference of the circle, means whole path, total arc length, which is 2 pi, and due to circumference, total angle subtended at the center is 360 degree, then distance AB is equal to 2 pi r divided by 360 degree into theta. This is our formula. You may use this formula, I will tell you. Then displacement. Initial position is A and position vector of the particle with respect to origin is OA vector. Finally reaches at B, then position vector of final position with respect to origin is OB vector. This is initial position, this is final position, and this is displacement. Let this displacement is S. Okay. The shortest path from initial to final position. Okay. From the triangle OAB, OA vector plus AB vector is equal to OB vector. You know the triangle of vector addition if two vectors are represented by the two sides of a triangle in magnitude and direction taken in same order, then third side is represented in magnitude and direction taken in opposite order, which represents the resultant of the two vectors. Okay. In the triangle OAB, see, OA and AB are in same order, means from O to A, then from A to B, in same order, means in anti-clockwise order, then third side in opposite order, means in clockwise order. Then the equation as per law of vector addition, we require displacement AB, then AB vector is equal to OB vector minus OA vector. So this is the case of vector subtraction. The method of vector subtraction is equivalent to the method of vector addition. Only negative of one vector is added with other vector. Then this is equals to OB vector plus minus OA vector. Then magnitude of AB means magnitude of displacement, that's equals to square root of OB square plus OA square plus 2 OB OA cos 180 degree minus theta. So according to the principle of vector subtraction, then magnitude of displacement is given as OB. OB is radius, OA is radius, length of OB is equal to magnitude of radius, and OA is also equal to magnitude of radius. OB square R square, OA square R square plus 2 OB R, OA R, cos 180 minus theta is minus cos theta, and finally it comes 2R square minus 2R square cos theta, and this is equals to 2r square into 1 minus cos theta, and as you know, 1 minus cos theta is equal to 2 sine square theta by 2 from a trigonometric formula. Then this is equal to square root of 2r square into 2 sine square theta by 2. Okay, I am writing here formula for magnitude of displacement. If theta is angle subtended at the center, then magnitude of displacement is given as length of line A, magnitude of displacement, or magnitude of displacement S is equal to 2 into 2 4, square root of 4 is 2, r square root over r, sine square theta by 2, and if it's sine theta by 2, this is formula for displacement. Okay, this is formula for distance. We may use all these formula for any known value of theta. The general known values are 180 degree and 90 degree. Let me prove that this formula is right. Suppose a particle moves along a circular path of radius r. It starts from A and completes a semicircular path and reaches r. Okay. Radius of the circular path is a and r. Then we have to find distance and displacement. We know distance is actual path, means the length of semicircular path. If radius is r, then distance is pi r. Then let's just see by using the formula AB. The curved path is 2 pi r divided by 360 degree into theta. See, if this is center, total angle subtended at the center due to semicircular track, or if arc is semicircle, then total angle is 180 degree and it comes pi r. 180, 362, 2 get cancelled, pi r. As we know, length of semicircle, then displacement. A is initial point, B is final point, this is radius r, this is radius r, then displacement is, magnitude of displacement is 2r. We may use this formula to get displacement. Displacement is S, then magnitude of displacement 2r sine theta. Here theta is 180 degree divided by 2, sine 90 is 1, displacement is 2r. As we know, also we may use this formula for another known value. Let a particle travels along a circular path of radius r. It starts from A and reaches at B, covers a quarter circular path. Okay. So path length is AB, means distance is AB. Let's say again, this distance AB means length of quarter circular path. For semicircular path, path length is pi r. For quarter circular length, pi r by 2. We know it. Then here, length AB is 2 pi r divided by 360 degree, and this is arc AB, subtension angle 90 degree, then theta is 90 degree. Then 4 pi r by 2, as we know. Length of quarter circular path, and displacement is A. From A to B, initial point to final point, this is radius, this is radius, this is 90. So this is base, this is perpendicular, and this is hypotenuse. Then displacement, magnitude of displacement is square root of r square plus r square is equal to root 2r. Then we may find using this formula magnitude of displacement. This is S, 2r sine theta. Here theta is 90 degree, sine 90 by 2. This is equals to 2r sine 90 by 2 sine 45, means 1 by root 2. Again see, this will come root 2r. These are known values. You can use any value of theta as given in question, maybe 60, maybe 120, maybe 30, maybe 45, whatever given. You may use the common formula. Okay. But the angle, the value of angle, sine angle should be known. Okay. Then next question. Next question, we are going to solve. Next question, I have not remembered the name. Let a wheel, I will use 2 bits of this question. A wheel of radius r rolls on a horizontal surface. Okay, a wheel of radius R rolls on a horizontal surface. Okay, a point P on the wheel is initially in contact with the surface. Okay, find the displacement of point P if the wheel moves taking half rotation. Taking half rotation. The wheel moves forward, taking half rotation. See, initially point P on the wheel is in contact with the surface. For half rotation of the wheel, the point P will subtend an angle 180 degree above the center of the wheel, means point P will reach at diametrically opposite side. But the wheel moves forward. After taking half rotation, let the wheel reaches at this point. Okay. Then point P is displaced to point P dash. So this is displacement from P to P dash. We have to find the displacement P dash means length of this straight line. Okay, this is shortest path. So the point P has moved and finally reaches at diametrically opposite point. Okay, let this point is O. For half rotation of the wheel, the path covered means linear distance covered by the wheel for half rotation is obviously pi r. For half rotation means for 180 degree pi r. Then OP dash, if radius is r, then OP dash is a diameter means 2r. See, POP dash is a right angle triangle. This is base PU, this is perpendicular OP dash, and this is the hypotenuse PP dash. We have to find length PP dash, which is magnitude of displacement, square root of from triangle POP dash, base PO square plus perpendicular OP dash square. Then this is equals to PO means pi r square plus perpendicular means 2r square, and finally we will get pi square r square plus 4r square. Then displacement is r square, bring it outside, r root of pi square plus 4. This is displacement of the wheel after the wheel taken half rotation and rolls forward. Okay. Then next bit, the wheel of radius r rolls on a horizontal surface. A point P on the wheel is initially in contact with the surface. Find displacement of the point if the wheel moves taking 1/4 rotation. 1/4 rotation means for 1/4 for half rotation, angle subtended at the center is 180 degree. For 1/4 angle is 90 degree, means point P would reach covering an angle 90 degree, but the wheel rolls in forward direction. Okay. Now, since the wheel is not here and moves in forward direction, left, this is the new position of the wheel. Some extent closer. Okay. Then point P has reached at this point, means making an angle 90 degree, subtends an angle 90 degree above the center. So this is original position, this is final position. So displacement is PP dash, we have to find it. Then radius is r, draw a perpendicular. Let this point is any point, let's take x, this is O. Then after 1/4 rotation, the linear distance covered by the wheel is pi r by 2 per quarter circular path. Okay. So this is radius, this is also radius, so OX is also r, and XP dash, this is P dash is also r. Then From the right angle triangle, I am writing the complete form. From the right angle triangle, from the right angle triangle PXP dash. PP dash is hypotenuse, PX is base, and XP dash is perpendicular. Means we have to find magnitude of displacement, length of straight line PP dash. This is 90 degree. Okay. Square root of PX square plus XP dash square. And here PX is PO minus XO. PO minus XO is PX. Then PO is pi R by 2. XO is R. Similarly, the perpendicular means XP dash. XP dash is equals to, as that of radius means R. Now you put your values in place of PX, pi R by 2 minus R, and in place of XP dash R, pi R by 2 minus R, in place of PX, and in place of XP dash put R, and you can solve it now. Okay. The next question. Next question is also very simple question. Okay. A cyclist completes its motion once on a square track of side 10 meter in 20 seconds. Okay. What is displacement of the cyclist? H of the cyclist at the end of 1 minute 10 seconds. Okay. We have to find displacement at the end of 1 minute 10 seconds. See, cyclist is moving on a square track. The side is 10 meter. So this is 10 meter. The side is 10 meter. Let the cyclist starts from it and moves on the square track. Completes his motion once on a square track of side 10 means he starts from it, again reaches at it. Time taken by the cyclist is 20 seconds. Means to cover a distance of 40 meter. Total path length is 40 meter. Time is 20 seconds. But we have to find displacement at the end of 1 minute 10 seconds. Then 1 minute 10 seconds. That's equals to 1 minute means 60 seconds. Again plus 10 seconds. Total time is 70 seconds. We have to find displacement of the cyclist at the end of 70 seconds. But the cyclist completes the square track in 20 seconds. Okay. Then we have to first find the number of turns in 70 seconds. For one complete path, time is 20 seconds. In whole 70 seconds, the number of turns is 70 seconds divided by 20 seconds, and it comes 3.5 number of turns. Okay. At the end of 70 seconds, the cyclist completes 3.5 turns. So the cyclist starts from it, goes on moving, and reaches at A. 1 turn, then again reaches at A. Second turn, then again reaches at A. Third turn. Third turn is complete when it finally comes back to it. Then 0.5 turn means half turn. Then for half turn, cyclist starts from A and reaches at B. This is half turn. So this is initial position, this is final position. So displacement is directed from initial to final position. This straight line we have to measure the length of line AB. First square, this is 90 degree. Then length here, straight line, which is displacement h, then magnitude of displacement h. For this right angle triangle, this is base, this is perpendicular, and this is hypotenuse. Again, square root of 10 square plus 10 square, that's equals to 10 root 2 meters. Okay, these are two easier questions, and you can attempt all the questions. Then next question. Next question. A particle moves on a regular hexagonal track upside A. A particle moves on a regular hexagonal track upside A. Okay. Find distance and displacement of the particle at the end of between third turn bit B, fifth turn, and C bit sixth turn. Okay. We have to find distance and displacement of the particle at the end of third, fifth, and sixth turn. Let's represent a hexagonal track, regular hexagonal track. Okay. Then the particle starts from A. This side is A, this side A, this side A. Okay. Moves on the hexagonal track. Okay. The particle starts from A. So obviously this point is B, means here first term. This point C here, second term. This point D, third term. This point E, fourth term. This point F, fifth term, and again at A, it is sixth term. Okay, we have to find distance and displacement at the end of third term. B. At the end of third term, the particle just crossing the point D, then path length means distance from A to D, actual path. From A to D, path length is AB plus BC plus CD, A plus A, that's equals to 3. Path length is 3 at the end of third term. Then displacement, A is initial point, D is final point. So this is displacement directed from initial to final position. To get it easily, just draw a perpendicular. This angle is 90 degree. Okay. A regular hexagon, this total angle is 120 degree, and the angle is, this angle is 60 degree. Now, from triangle, right angle triangle A, B, D. This angle is 90 degree, this angle is 60 degree. Then we may use cos theta cos 60. Base divided by hypotenuse means AB divided by AB, B by H. Then AB is A divided by AD, means AD is displacement, magnitude of displacement is length of line AD, then displacement, magnitude of displacement is length of line AD, that's equals to A divided by cos 60. This is equals to A, cos 60 is 1 by 2, means 2A. So distance is 3A, displacement is 2A at the end of third term. Then bit B, at the end of fifth term, bit B. At the end of fifth term, see this is the fifth term. To reach at point A, fifth term, to reach at point A, the particle has traveled from A to B, then from B to C, then from C to D, then from D to E, then from E to F. Then distance. Total path length A plus A plus A plus A plus A means 5. Then displacement. Displacement is shortest path directed from initial to final position. The particle starts its motion from A, and at the end of fifth term the particle is at F. So this is displacement, the shortest path directed from A to F. Then this is A. Magnitude of displacement is A. Then C bit. At the end of sixth term, C. At the end of sixth term, the particle has already reached at A. A is initial point. Again, A is final point at the end of sixth term. Then distance. Distance is actual path length, means whole path along the semicircular track, along the hexagonal track. Then distance is 6A and displacement is 0. Because the body has again reached at the initial point. So A is initial and A is final. Okay. The last question. I am not writing the last question. You will just see. You can estimate and can write the question. Only just imagine a cubical container, okay? A hollow cubical container. This point is a particle or a point moves inside a hollow cubical container of side A. Side of the cube is A. The particle starts from O, reaches at A, then moves from A, reaches at B, then moves from B, reaches at C. Starts from A and moves along the path from O to A, then from A to B, then from B to C. We have to find displacement. See students, this is one curve of the cubical container and C is the opposite curve. Inside a cubical room, you can imagine the straight line joined from one corner to another opposite corner. This is displacement. Okay. Let's imagine this is along x-axis, this is along y-axis, and this is along z-axis. See, AB is parallel to x-axis. If this point is B dash, then length of AB is equal to length of OB dash. Similarly, length of BC is equals to length of OC dash. This is along y-axis, this is also along y-axis. So we may write OA, displacement OA is along z-axis, displacement along z-axis, and displacement OB dash is along x-axis, so displacement along x-axis. Similarly, displacement OC dash is along y-axis, so we may write it SZ, and resulting displacement we may join it. This is the resulting displacement S. The resulting displacement is Sx vector plus y-axis OC dash. This is Sy. Okay. Sx vector plus Sy vector plus Sz vector, and in regular form vector addition, this is Sxi cap plus Syj cap plus Sz cap. And magnitude of displacement, as you know, using the rectangular components, square root of Sx square plus Sy square plus Sz square. Since the side of the cube is A, then this is equals to square root of A square plus A square plus A square, and our answer is root 3A. Okay. But these are some fundamental questions. This is the end of lecture 3, and finally I would like to say these questions are not sufficient. Okay. These are only fundamentals. So it's advisable do some more questions from a regular book and from objectives, so that you can strengthen your standard and will have confidence to appear in any form of competitive. So carry on your labor. So I am just doing my best, trying my best. Then in lecture 4, we'll proceed the subject. Okay. Thank you. Thank you, students, for watching. Thanks.